Hey guys, so we're looking at homeostasis today, and we're looking at that in relation of how the body controls its internal body temperature. Okay, so I mentioned homeostasis as the main thing we're looking at, and this will be something we look at in relation to body temperature. We'll look at it in relation to blood glucose level. We'll look at it in relation to water levels. It's something that comes up a lot. But what that word means is maintaining a relatively steady state despite changes in the environmental conditions. So obviously we live in a constantly changing environment. We never live in a place where the temperature is always staying the same. We'll just focus on temperature for now. So our body's got to be able to respond. If the temperature's too small, the reactions that keep us alive can't happen fast enough. If temperatures are too high, the enzymes that allow those reactions to happen get denatured and they won't work. So again, the reactions to keep us alive can't happen, so we die. So keeping our temperature relatively constant is really, really important. Okay? So when we talk about homeostasis, we say it is mediated by both the endocrine system, which is hormones, and the nervous system, which uses electrical signals. So your endocrine system, which is hormones, that involves hormones themselves, which are messenger signals in your blood. It involves the glands that produce them, and then the cells that respond to those signals, okay? And then the nervous system obviously involves your nerve cells, your neurons that transport messages, and it involves your brain and your spinal cord as well, because they help coordinate the signals that come to you. So when we're talking about this, about homeostasis and how the body keeps things in a constant state, we talk about it in relation to negative feedback. And what that means is if the conditions change significantly, if they get too high or too low, the body will cancel out that change. The body works to cancel out that change, okay? And I've got a bit about negative feedback there, and I've also got a little diagram to show the basics of what happens when change happens in the body. So there's some sort of stimulus, so there's a change from normal conditions. That's received by receptors, so cells that receive the signal. The message goes to your central nervous system. Your central nervous system is basically your spine and then your brain. Then that makes some sort of response. So messages get sent to your effectors. An effector could be a muscle or it could be a gland that produces a hormone. And things happen to return the conditions to normal. Okay? So the idea of negative feedback is not necessarily about things getting lower, it's about cancelling out any changes that happen, okay? So we're going to look at this now in relation to thermoregulation. So as you probably know, the human body is happiest at a temperature of around 37 degrees Celsius. Even a few degrees above or below that and you'll be feeling seriously uncomfortable. A temperature of say like probably as low, I should say, as 43 degrees. If you get your temperature that high, that could probably potentially be fatal. And it doesn't sound like a lot, a 6-degree difference above the regular temperature, but it can be very, very serious. So our body wants to keep the body temperature in a really narrow range. So, as I said, anything that rises or falls significantly from that around 37-degree mark needs to be swiftly dealt with through negative feedback. So anything where the temperature rises needs to be cancelled out. And we'll look at how that happens specifically in a second, but I want to show you just a couple of things that your body does. So when the body is too cold, it may do vasoconstriction. Vasoconstriction is where your blood vessels really narrow, and they sort of push further down, they move further away from the surface of your skin. So when that's happening, it's harder for energy loss to come from your blood near the surface of your skin. Your metabolism may increase. So your metabolism are your biochemical reactions, and that uses up energy, and they may increase when you're cold in order to generate heat in your body. There may be behavioural changes. So obviously when it's cold, we put on layers. Animals that don't have access to clothes may do things like seek shelter from the cold, so there can be behavioural changes. And then there's the changes on your skin, so goosebumps and raising hair or fur. When your hairs stand up when you're cold, when your body hairs stand up when you're cold, that traps a small layer of air close to your skin, and air is a good insulator of heat, so that helps keep you warm. Quite a cool little fact, the smallest muscles in the human body are the muscles that make those hairs on your skin go up or go down. They're called erector pili muscles, and yeah, smallest muscle in the human body. Could be a trivia question at some point, you never know. So as for actions your body does when it's too warm, it may do vasodilation. So vasodilation is the opposite of vasoconstriction. So your blood vessels move further to the surface of your skin and they get wider. You may notice that on a hot day. If it's a hot day, you may be able to see your veins on your forearm much clearer than you could on a cold day. That's because they've got wider, so they're more visible, and that allows more blood to pass to the surface of your skin and radiate heat to your surroundings. So sweating may happen through sweat glands. Sweating causes heat loss through evaporation, so that's good. Again, there'll be behavioural changes. So things to help when they get too hot. For example, that could be seeking shade, could be seeking water, things like that. Lowering hair or fur as well, be really important. And then think about certain animals like dogs. Panting is a way of getting rid of excess heat as well. So that's the things that we can do in order to control when our body is getting too warm or too cold. These sort of things only happen in warm-blooded animals. So, or at least most of them, the behavioural changes happen in cold-blooded animals. But the other things only happen in warm-blooded animals, i.e. mammals and birds. Okay? So as promised, here is a negative feedback loop for thermoregulation, for regulating body heat. Okay? So basically, if we start here, the temperature is at its normal way, and then either it rises or falls above normal. So we'll go for the blue one first. We'll talk about the body temperature falling. So when that happens, the hypothalamus detects change. The hypothalamus is in your brain, and that's really important in detecting changes in things like body temperature. Okay, so your hypothalamus detects the change, and then in response to that, it will send a number of signals. So it might say to increase the metabolism, which we were talking about earlier, to do shivering to generate heat, to raise the body hairs, all those sorts of things. As a result of that, the heat is generated and the body temperature returns to normal. On the other hand, if the body temperature rises, again, the hypothalamus detects the change. This time changes will be things like producing sweat, reducing the metabolism. The result of those things is the body temperature falls because heat is being released, and then it returns back to the normal temperature. So both of those things are negative feedback because both of them are cancelling out the change that happens. Okay? So that is really everything for the overview of homeostasis and thermoregulation through negative feedback. If you want to pause it to study this in a bit more detail, just try and position it so you can see it clearly, none of it being cut out. Hopefully that's okay. And that's it.